First time I ever went to a reef, I was 19 years old. I went on an expedition to Belize in Central America, and I loved it. And I remember leaving that island and thinking, I'm going to be back. This is going to be important to me, and I've been back a few times. I came into this from the work I was doing in Belize, which was trying to design marine protected areas. And it was really striking to me in the early 1990s how little science there was to guide our decisions. I mean, the reef's enormously complicated, but the science has matured now to the point where we can really bring a lot of our understanding together. We're combining literally hundreds of individual studies that allow us to build a model of how this system is working. To me, what's really nice about the Reef Restoration Adaptation program is that it's looking at restoration in the broadest sense. So it looks at all of these sorts of options that are available. You know, some are very high risk and probably can only be done at small scales. Others are very close to business as usual, but just doing more of it. And so our contribution here is helping to put these various restoration activities into a context of, so if you were to do this, what's the reef going to look like? The other thing that we learn from studying reefs is how humble you need to be when you're dealing with nature, because the amount of times now that we have been surprised by the way in which reefs have reacted and often recovered from a disturbance teaches you that just when you think you understand something, nature has a few surprises up its sleeve, and we have to be very careful when we're making projections about the future that we don't lose sight of the fact that we're dealing with a very resilient system underneath all of this. I don't think there's much doubt that the biggest challenge the reef faces is from climate change. I mean, that climate change is obviously a much bigger issue than just coral reefs. But we mustn't at the same time lose sight of the importance of local interventions, and the science that we and others have done is very clear. If you want to have reefs by the end of this century that are really quite nice reefs, you need to have both of those things. You can't just focus on climate and ignore the local problems, and you can't ignore climate. You need both of these things to work together. And I think one of the great things about Australia is that the level of discourse between management and science is probably better than anywhere else in the world with respect to coral reefs. And that's why it's such a joy to work here, because the people who are responsible for managing the system place a very high importance on science. Of course, they're also pragmatic, and not, in fact, only a small fraction of the science that is done will directly affect what people do on the reef in terms of managing it. But the pathway to help people make better decisions is there, and there's a whole infrastructure to support that. And the reef has a future, and the idea that there wouldn't be a reef is nonsense. And the reef is going to change. The question is, how much is it going to change? And people are always going to have a very strong relationship with that reef, no matter what happens, and we need to manage that transition. And obviously our objective, and collectively, is to minimize the amount of change, but it'll still be fantastic in places. We just have to make as much of it as possible, as functional and useful and beautiful as possible. We just have to make sure that the reef is as in good a state as we possibly can achieve.